All right, everybody, welcome back. We're going to go through Unit 1, Lesson 6 and Lesson 7. I'll do my best to make my way through this here. Hopefully it sounds okay. And keep in mind that anything that you're not feeling comfortable with, we'll review when I return to school before we take any sort of an assessment. So, just do the best you can with this as an online lesson, and then we'll review everything when we need to when I return. All right, let's jump into it here. Hopefully you've already got the black and white images activity sheet. If you haven't got that activity sheet from the substitute, can you please pause the video and ask the substitute to pass that out to everybody, because we'll need that for the next lesson here. For now, you can grab your computers, head to code.org on Unit 1, Lesson 6 there, and then grab your journals, and then you'll need your activity sheet, like I said. All right, let's jump into it here. So the first part of this is warm up here. You can take a look at it. It says brainstorm with your partner. Again, we'll do this individually since I'm not there today. You can do this individually. What you think this list represents. So it's got a list of numbers there. Take a second to look at that. You can pause the video if you need to and see if you can figure out what those numbers represent there. So those are some numbers that represent something else. And give you a second to think about it. Okay, so notice that these numbers are spaced, so maybe that will help you, right? So we've got 1 and then 2 and 14, right? And then 7 and 4 and 10 and 31. And I'll give you a clue if you haven't come up with it yet. And the clue is that these numbers are not related to each other. So there's no pattern that goes from one to the next here, right? So these are kind of like individual pieces here, but they all are using the same encoding method to convey what they're trying to convey. I'll give you another second to think about it here. All right, so if you think about this here, if you haven't come up with it yet, if you think about it, we can think of the first number here as the month and the second number here as the day, and then we can see that these are all major holidays here, right? 1/1 would be first day of the year, right? So that's New Year's Day, and then 2/14, Valentine's Day, 7/4 would be the 4th of July, and then 10/31 would be Halloween, right? And so this is just an example of how we can use numbers to represent something else, which is an example of abstraction, which we're going to get into right now. So in your journal, you're going to need your journal here. So in your journal, you can flip to a new page here and take a look at these samples that are on the screen. It says using only numbers, you're going to need to communicate these samples to a partner. So we're not going to actually do this with a partner, but what you're going to need to do is you're going to need to encode these samples. So you're going to need to come up with some sort of a representation using just numbers that would convey these words here, the hey, the TTYL, and the morning, right? So turn those things into some sort of a system that can be conveyed using just numbers. So you might have something like this on your screen where you've got A is 1, B is 2, and so on and so on, and then you can go ahead and encode those words or those messages that are text into numbers, right? And then the idea is that we can then take those numbers and eventually turn them into binary, right? We're not going to do that right now, but remember, your computer kind of speaks in binary. That's everything that we have is just the ones and the zeros. So if we can go from text into decimal numbers, then we can go from decimal numbers into binary numbers, and that's kind of how your computer is thinking, right? All right, so I'll give you a second to go ahead and create this system here, right? You can jot down the entire alphabet and create a system. It doesn't have to be exactly like I have the one there, although this is probably the most obvious example, but you can come up with something different if you'd like, but you need some way to go from text into decimal numbers here. So you can go ahead and pause the video, fill that out in your journal, and then when you're ready, we'll move on and we'll try out a couple of these in your journal. Okay, so hopefully you've got your system all set up in your journal there, and then underneath where your system is or on a new page, you can go ahead and start to encode these phrases, these words and phrases using your system. So the first one is the phrase, oh no. So you've got to go ahead and turn that into your decimal number representation, right? So you're taking your text, you're turning it into a decimal number representation. So go ahead and turn that "oh no" message into your number representation there. You can pause the video, go ahead and complete that. All right, and then when you're ready, we'll move on to the next one. So I'm going to give you another message here. Okay, so your new message is great with the exclamation mark. So I want you to keep in mind two things here. Number one, we obviously have an exclamation mark, right? So if you don't have that in your system, you'll need to add that to your original system. So you can go back up or to the other page that you wrote your system on. You can add that to your system there. And then I also want you to notice that this is a great with a capital G. So that might be something else that you have to add to your system. So if you need to make modifications to your system, you can go ahead and pause the video, add those pieces to your system, and then make those additions to your system, and then go ahead and encode that message, the great with the capital G and the exclamation mark, into your numerical representation there. Go ahead and pause the video, take care of that, and then we'll come back together, go on to the next slide. All right, moving on here, I'm going to give you another message. The next message looks like this. So we've got free at 5, we've got capital letters, we've got some punctuation there with the question mark, and now we've also got a number, right? So how are you going to distinguish between numbers and the numerical representation numbers that you're using, right? So go ahead and see if you can add something to your system there so that you can do that. Right, so I'll give you a second. You probably got to make an addition to your system on the original page. So go ahead and work on that. You can pause the video, and then we'll come back together after you've encoded this phrase here, which says free at 5 with a number in it, a capital letter in it, and a question mark in it. All right, and then the last one is going to look like this. It says, see ya tonight, right? The last message. And we've got capital letters. We've got a number in there. We've got the punctuation with the exclamation mark. So we've got all those pieces there. Hopefully your system at this point has everything that it needs to encode this or to represent this just using the numbers. So I'll give you a second to go ahead and do that. You can pause the video, write down that last message with your numerical representation. All right, and now we'll move on here. So I want you to keep in mind, right? I don't know what your system is, right? And you might not have the same system as somebody else, right? But as long as you've got a system that has a set of rules, right? If we were going to communicate these messages with somebody else, we would need to agree on your set of rules, right? Which could be different than mine right now, but we would need to agree on some set of rules. And then as long as we agree on this set of rules, we can communicate using these systems. And that's what these computers are doing, right? That's what we're doing when we have cell phones and computers, and we're turning text into decimal numbers and then the decimal numbers into binary numbers. Is we're coming up with an agreed upon set of rules that everybody kind of knows. You know, letter A is represented with a 1, capital A is represented with a 2, and so on and so on. We're agreeing on this set of rules, and then everybody uses that set of rules, and then we can communicate with each other, right? So as you look through your messages here, right, you can think about how many bits would your system need to convey these messages, right? So as your system increases in size, right, you need more decimal numbers to represent all the things, like we had to add punctuation and capital letters and numbers, right? So as we increase the number of things that we're trying to represent, we have to increase the number of decimal numbers that we're counting to, which then increases the number of bits that we need, right? And if our computer doesn't have enough bits, that's where we would hit this overflow, right? Or we would hit this rounding error like we talked about yesterday, okay, in the previous lesson, right? So, our computers can, convey all these messages that we just looked at, right? Because these are pretty simple things, but you have to keep in mind, right, that might not always be the case. We may run out of space where we don't have any more bits, so we can't add anything to our system, and that's where we would hit that overflow. So this brings us to the ASCII standard encoding method. So this is what I was referring to before, is that this is kind of the agreed upon set of rules that all computers or most computers use, right? So this is an encoding method that is like preloaded into our computers, right? Our computers are programmed with it, and this is kind of the agreed upon set of rules that we're using without even really knowing it. It's ASCII, American Standard Code for Information Interchange, but it's pronounced ASCII when you use the acronym there. I wrote it down in the right corner if you want to jot it down there. But this is the agreed upon set of rules that most computers are using to encode messages, so to turn text and emojis and things like that into decimal numbers, and then those decimal numbers into binary numbers. So you can take a second and you can pause the video and look through this really quickly. You don't need to memorize anything like that, right? You can just think about what's the same as the system you created, what's different, what's interesting, or what's surprising about it. Okay, you don't need to write any of that down. You can just kind of brainstorm it in your head. Just take a look at it and see if anything jumps out to you. I'll give you a second to pause it and look through it. I'll zoom in slowly as we go here. All right, so you can see that they've got all of the uppercase, lowercase, all these different characters, right? Numbers as well, right? The numbers 0 through 9 there. And then they've got a numerical representation, right? A decimal numerical representation that starts over there at number 32 and runs all the way to 126. And then those numerical representations are then converted into binary representations, which you can see in that middle column for each one. Now, something that might jump out to you might be wondering about is, why does it start at number 32, right? And so the first numbers, right, the numbers that are below 32 are actually designed for things like backspace and forward space and tab, so things that we wouldn't, necessarily be able to see in a table like this, but you have to consider that those things need to be programmed into computer too, right? So that's what the first 32 numbers are designated for, things that don't necessarily show up as punctuation or as text, right? But they're still going to be something that needs to be programmed into a computer there. All right, so let's summarize a little bit what we just talked about there. You can go ahead and kind of jot down this wrap up here. Remember, like I said, you don't need to memorize anything on that ASCII encoding method. You just need to know that it exists. It's an agreed upon set of rules that most computers follow. So let's look at the takeaways here. You can pause the video, jot these down. I'll kind of talk through them first here. So lesson 1.06 takeaways. There are many possible encoding systems, right? You created a bunch on your own, or you may have had the same one as a partner, or maybe you didn't have the same one, right? But there's a bunch of different ways to do it, and there's no right system, right? It's just that everybody has to agree on a system in order to communicate with each other. And that's what's happening with the ASCII method, right? Is that most people are agreeing that that's the system that we're using. And so then we can then we can use that as a way to communicate with each other. And then, like we mentioned, adding more characters to a system may require more bits, right? The more things you add, the more information you're adding, the more bits that you need, like we've talked about in the past. And remember, in a real world, we may run out of bits. So we might not be able to store all the characters that we need, and that would lead to this round off or overflow errors, right? So, ideally we would have an infinite enough amount of bits that we could just continue to add characters forever and ever and ever, but that's not realistic, right? We have a finite space that we can add bits, and so we may encounter this round off or overflow issues. And then the last thing is the vocab word abstraction. This is going to show up throughout the course here. So this is when we create a simplified representation of something more complex. Okay, so this is this is a big idea here where we're creating a simplified representation of something more complex, which is what's happening here. So we're taking these text strings, right? These messages that you are encoding, right? We're taking them and we're representing them just with numerical values, decimal numerical values, right? So we're taking these kind of complicated, not really in this case too complicated, but complicated text strings or phrases, and we're representing them with something a little bit simpler in just these decimal values, right? And so that's what's happening with the computers, is that these things are all examples of abstraction where we're representing something that's more complex with just ones and zeros, right? So it's just these combinations of ones and zeros that represent everything that we see on a screen: images, music, text, right? It's just those are all examples of abstraction. All right, so if you haven't had a chance to copy all that down, you can pause the video here and we'll move on to the next section. So the problem that we were trying to solve today, right? You don't have to write this down if you don't want to. You can just take a second to think about it. The problem that we were trying to solve today is that we were trying to turn these text strings into numerical representations, right? Which is an example of abstraction, right? And this is just what I just talked through. This is just a visual representation of that, right? So you can see that what we see is the text all the way on the left there, right? So that text shows up on our phone, but what's happening is that text is being, in the background converted to the ASCII encoding, right? So you can see the ASCII decimal numbers there: 104, 111, 119, right? And then that is all being turned into the binary on the computer's end. Okay, so it's kind of like these three steps here. And that's an example of abstraction. We don't have to think about this layer when we send a text, but every message is really just zeros and ones. So what's another example of abstraction from your everyday life? Something where you don't completely understand how it works, but you can still use it with confidence, right? And these things pop up all the time, right? So you think about this, maybe you don't know a lot about cars, right? But you know that, if you turn the key, car turns on and you're able to drive it, right? That's, at least for me, I don't know a lot about cars, so I don't really know what's happening inside my car. I don't know what's making it go, right? So that would be an example of abstraction where it's something that's, pretty complex inside the car, but the simple version for me is I just turn the key and turn the steering wheel, right? And that's it, okay? Or maybe when you turn a light on, right? That's a simple, something simple for you. You're just flipping a light switch, but you've got all this electricity going on in the wall, right? All these wires and things like that that are creating the light to turn on. Okay, so those are examples of abstraction where we have this complex stuff kind of happening in the background, okay, but it's being simplified up front to you. Okay, we're going to move on to lesson 7. This is where you'll need that activity sheet. So if you need to, go ahead and take a break, right? You can stand up, stretch your legs, okay? And we'll move on to lesson 7 here. You will need that black and white images activity sheet because you will jot some things down on that. Okay, so think about this idea here on the warm-up. Okay, you don't need to write anything down here. You can just kind of think about this. It says you recently did some online shopping and are expecting a package to arrive in about a month. The delivery service has a tracking system which reads the location of the package. Okay, so like you order something from Amazon and they'll send you text messages on your phone, every so often about where your package is, right? So it's tracking your package. It'll give you updates. Okay, so you've got options. It says how often would you want the location to read? Do you want it to be updated? You want these text messages to be sent to you every week or every day or every hour or every minute, right? So you've got to think about that, right? You don't want to have these text messages come in every minute, right? Because that would just be like rapid fire texts and there wouldn't be much change in them. But at the same time, you don't want it every month, right? Because, there's a lot's happening in between there. So you've got to kind of pick this happy medium somewhere where it's, it's reasonable, right? It's helpful. Okay? You know what's going on, but it's not over the top. Okay. And that's going to be something that we look at here when we talk about sampling, right? So you can head to code.org on Unit 1, Lesson 7. There's a video there that's going to explain to you how to use this, what they call a widget. Okay, it's a black and white pixelation widget. And it'll give you a quick rundown of how to use the widget. It's not too complex. If you mess around with it, you can probably pick it up. And if you have questions, you can ask a neighbor and they can probably help you with it. So go ahead and pause the video, watch that, pause this video, flip over to code.org, watch that video, and then come back together here when you're ready. So I'll give you a second to pause the video and do that. Okay, so hopefully you've got an idea of how to use that pixelation widget. If not, ask a neighbor. They can help you with that. And we're going to go through levels 2 and 3. So those are the bubbles 2 and 3 on Unit 1, Lesson 7 there. And you can complete those tasks that they're asking there, right? You can see it's just, you're going to use those binary numbers to create those images that are there. Okay, so go ahead and do that. Notice you can, when it asks you to create, for example, the first image is this A, right? You've got to set what the dimensions are of the widget, right? So that's the first step, set the dimensions of the widget, right? If it's 3 by 5, then you've got to set that as 3 by 5, okay? And then you can go ahead and use the ones and zeros to turn the switches on and off and create the image that they're asking you for there. Right? If you ever lose track of what the image is, you can always just re-click on the bubble and it'll pop up the beginning prompt again for you. So you can pause the video, you can work on that part for a few minutes there, and then come back to the video when you're ready. Right now you're working on levels 2 and 3 on the pixelation widget. Okay, so hopefully you completed levels 2 and 3 on the pixelation widget. We're going to slide over to what we'll call an analog image here, and we'll talk about the difference between an analog image and a digital representation. Okay, and so this is where we're going to need the activity guide that has those little pictures of the swan on there, or the duck. Okay, so let's talk about sampling an analog image. You can go ahead and jot this down. I'll zoom it in here. So analog is something that has a continuous representation. Right, so you can think of this like, I think of the analog kind of like the real world, like it's always changing, it's continuous, right? And then what we're going to do is we're going to come up with digital representations, right? So we're going to kind of take these like miniature snapshots a certain amount of times to represent, you know, the real world, or what's always changing, this continuous analog data here. Okay, and so the more snapshots that we take, the better representation we'll have. Right, maybe you know that you've seen those little flip books, right, where you flip through the flip book, and like if you flip through it really fast, it kind of looks like the characters are moving in the flip book. Okay, so the faster that you, or the more pages that you have in that flip book, the more realistic it's going to look like, right? The less pages you have in that flip book, the less realistic it's going to look like, right? And so that would be our sample there. Right, so the more samples that you take, the more realistic it's going to be. The less realistic it's going to be. But the main thing I want you to know is that analog is something that's continuous, right? It's kind of always changing. And it's like, I think of it kind of like as real life. You can also think of analog as like, maybe you know what an analog watch is, or an analog clock, right? So think about a clock on the wall that has the hands, right? That go around in a circle. Maybe you've seen the analog clocks where it has the second hand, and the second hand goes in a circle continuously, right? It just keeps moving. That would be analog, where it's hitting all the seconds and all the pieces in between the seconds, right? Then there's these other analog clocks, right? Or I should say there's these other clocks, which are digital clocks, right? And they'll just flip from minute to minute to minute, okay? And so obviously the seconds are running in the background, but we're just getting a digital representation of what's happening. It's not quite as exact, right? Because it's just showing us the minutes on this digital clock here, right? Whereas the analog clock is showing everything that's happening because the second hand is spinning in a circle there. Okay, so it says we can represent analog image digitally by taking a sample. The smaller the sample, the more pixels, and obviously more pixels means more bits. and it's also going to make the image more clear. So I know that was a lot of information there, right? If you're feeling a little bit overwhelmed, that's okay, right? I think when you go through this activity, you'll pick it up here. So go ahead and move over to challenges A, which is level 4, and B, which is level 5 on code.org. So bubbles 4 and 5 there. You'll use your activity sheet to answer some questions there, and you'll also reference it to use the images there. And you can go ahead and create those images on those bubbles. You can pause the video. I'll give you a few minutes to get through that, and also complete the activity guide by filling in the answers on your sheet, which you'll upload to Canvas today. So go ahead and do that. You can pause the video. We'll come back together in a few minutes. Okay, let's look at the wrap up here. It says in challenges A and B, practice sampling the same image twice. The second time we did a more frequent sampling by using smaller squares. So you did a more frequent sampling, right? So you're taking more snapshots there by sampling smaller squares. What are the pros and cons of sampling an image more frequently? I'll give you a second to think about that, right? What are the pros and cons of sampling an image more frequently? So you can jot this down if you're a little bit unsure about it, but the pros of sampling an image more frequently is that you're going to get a clearer picture, right? So, the more snapshots, the more samples that you take, the clearer it's going to be, the more realistic it's going to look. Okay, the cons are you need more bits, right? Because if you're taking more, you have more data, which requires more bits, right? And sometimes you have a limited amount of bits that you can have. So, you might not be able to take as many snapshots or as many samples as you'd like, right? So then it's going to require more bits. And you can jot down these definitions here. We'd already talked about analog data a little bit, but you can add this to the definition we had going before. This is data with values that change continuously or smoothly over time. Some examples of analog data include music, colors of a painting, or position of a sprinter on a race. And then digital data is data that changes discretely through a finite set of possible values. And then sampling, this is a process for creating a digital representation of analog data by measuring the analog data at regular intervals called samples, right? So these are the samples are the snapshots that we're taking, a bunch of different snapshots, and piecing them together to create this digital representation of something that's continuous, of this analog data. The more samples that we take, the more clear it's going to be, right? The closer it's going to be to the original representation, okay? But also the more bits it's going to require, because more information equals more bits. All right, so that's pretty much everything from those two lessons there. You can fill out the check for understandings for those lessons. Anything that's not super clear, we can clear up before we take any sort of an assessment, right? And so don't worry about that. We'll take a pre-test probably on Friday before we get to an actual assessment. That way we can make sure everybody's on the same page on all of this information here. But if you've got any questions, feel free to reach out to me. You've got the remind code now that's posted on Canvas, so please make sure you sign up for that, right, so that you can communicate with me more easily. And of course, you can always send me an email if you need anything. All right, thanks for watching. Hope to be back soon.